Good evening, everyone. Welcome to day 8 of our 15 days free training program on Python for AI. Before we move on to day 8, let's quickly recap what we learned till now. So, we have started learning data types in Python, and there are 14 data types mainly, and they are classified into six types or categories. Firstly, we've learned about fundamental data types. So, in that, we have int, float, boolean, and complex. So, int values are the values which store whole numbers, and float values stores decimal or real numbers, and also the floating point values. And boolean stores true or false values. And here the complex stores the real part plus imaginary part values, like 2 plus 3j. And then we have sequence category data types. So in this we have string, bytes, byte array, and range. So the purpose of sequence category data types is to store ordered collection of values. So it stores sequence of values or characters. And then moving on, we've learned about list category data types. In that we have list and tuple. So list and tuple stores multiple values. So these multiple values can be of the same data type or different data type, or it can include both types. And list and tuple also allows unique values and duplicates. So the main difference between list and tuple is list is a mutable data type and tuple is immutable data type. So list can be modified and tuple cannot be modified. But if tuple has elements which are mutable like list inside of any tuple, so that content of that list can be modified. But the whole structure of the main tuple cannot be modified. So list we can write with square brackets and tuple we can write with parentheses. And then we have learned about set category data types. So in set category data type, we have set and frozen set. So here set is a mutable type and frozen set is the immutable type. So what's the difference between list category data types and set category data types is these list category data types allows both unique values and duplicates, right? But set category data type only allows unique values. It won't allow duplicates. And also, set category data types internally uses hashing. So this hashing is used to store our values. So that is why there won't be any duplicates, and this hashing will help us to have fast membership testing. So if I want to check some value, let's say 10, if it is in our set S. So this is the membership operator. So if I want to check if the element 10 is in set S, then what happens is firstly it will calculate the hash value of 10 and it will get some value, right? In that location, we'll be checking directly. If it is present in there, we'll be getting true, and if it is not, we'll be getting false. So in the same way, we can store the elements also, and in the same way we can retrieve the elements. So its time complexity is O of 1. So it is a constant time. Even if you have 10 elements or 10,000 elements, the time complexity will be same and we'll have a faster retrieval. Okay. And then today we'll be learning about dict category data types and NoneType category data types. So let's start. So firstly, we're gonna learn about dict category data type or dictionaries. So first, let me ask you something. If I want to store some students' marks, let's say. So if I store it like Ram scored 80 or else Ram, he scored 85. So if I store in this way, it will be good, or if I store it in this way, it will be good. So which one looks more meaningful? So yeah, this one looks more meaningful because here if you see there are like some different values here which are separated with a comma. But here if you see Ram colon 85 looks like he got 85. So they are like connected. So this way looks more meaningful, and this is the dictionary part we are talking about. So what is a dictionary? So dictionary is one of the predefined class, and this stores data in the form of key value pairs. So for example, let's say we have a variable or dictionary that is student, and inside of that I have Ram who scored 85, and then I have one more person, let's say Raj. So he scored 90. So if you see here, these values Ram and Raj, these are called key values. And here 85 and 90 are called as values. So for this key, this is the value. So for Ram, the key Ram, the value is 85. And for key Raj, the value is 90. And here the main thing is the key values should be and must be unique values. If I have one key as a RAM and I cannot give one more key here as a same name. Okay, so these key values must be unique such that you can get the value, corresponding value from that key. And here values can be duplicates. Like two students can have the same marks, right? So in that way, the values can be duplicates, but the key values should be unique in a dictionary. So if you see a real dictionary also, there will be a word, right? So the word will be unique, but it can have many meanings like synonyms. So the word or this is the key that should be unique, and meaning they can be duplicates. That is the value here. The key value pair, right? That can be duplicates also. So that is how we can link our real world dictionaries with dictionaries in Python. So the important rules here are the dictionary is represented using curly braces. And inside of this curly braces, you will be writing the key value and the corresponding value for that key. So in this format, you will be writing dictionaries. So here, one more important thing is the key values must be immutable data types, or you can say hashable data types. So as you know, dictionary also uses hashing, just like sets it use hashing. So that is why here the key values must be immutable data types. So immutable means, as we know, the immutable data types are int, float, string, boolean, tuple, and frozen set. So key values can only be int, float, string, boolean, tuple, and frozen set. So that is because only these can be hashable. So as these are immutable, we cannot change the values, right? So what happens is we can get the hash value of the key, and there we can store our value. But if I have the key value as a mutable one, like list, or let's say set or one more dictionary. So these are all mutable types, right? So the keys cannot be mutable because there will be hashing performed. So we cannot have list, set, and dictionary data types as our key values. We can have all these values as the key values. And also, dictionary is a mutable data type. So dictionary is a mutable data type because we can change or update the keys and values. So when we have the keys and values, you can change these and update these. So the value is only the mutable one and key is the immutable one. As we just learned, we use immutable data types for key, right? So key is immutable. You cannot change the key. And based on this key, you can change the value. Only the value is mutable here. And keys are immutable. So I can use key. Let's say how we can use it is I can have the dictionary name and I'll give the key and I can give equal to assignment operator and I'll give the new value here. So what happens is when I do this, this will be updated to key is to new value. So in that way, the values are mutable, but key values are immutable. So you can access these values using the keys. And here in dictionaries, there won't be any indexing or slicing kind of thing. There will be only keys and values, and you can access this value using the keys. So dictionary is not position based, it is key based. So dictionary is a key based data type. And then as we know, dictionary uses hashing. So that is why same like sets, dictionary also uses hashing. So that's why it has a fast lookup. That means we can search elements very fast in a dictionary and the time complexity is same as set, that is O of 1. So this is the average time complexity. O of 1 means it will take a constant time for searching any value. So if there are 10 pairs of values or 1000 pairs of values, it will take the same time to get a value when you give the key. So that is why it will have very fast lookup. And also, one more main thing you need to remember is earlier dictionary data type was unordered. Like before Python 3.7 versions, before they are all dictionaries are unordered. But after we got Python 3.7 versions plus versions, all the versions after they maintain insertion order. Before dictionaries used to be unordered, but now for the latest versions, they maintain insertion order. So in which order we'll insert them, in the same order they'll be displayed. And the two types of dict objects are empty dictionary and non-empty dictionary. So non-empty dictionary is the one which contains elements and whose size is greater than 0. And empty dictionary is the one which does not contain any element and size is 0, and here size is greater than 0. So let's move on to the coding part so we'll understand it better. So if you want to create an empty dictionary, you can use the curly braces and you can just assign your variable and you can give this curly braces to the variable and this will be an empty set. So let's run this. So here D is an empty set and as you can see this is a dict data type and if you see the length of D it's 0. So As this length is 0, this is an empty dictionary. And you can also create an empty dictionary using this dict function. So as you can see here, we have an empty dictionary and length is 0. So using these curly braces or dictionary function, dict function, you will get an empty dictionary. And then for this empty dictionary, I've created a D dictionary, right? So I want to insert some elements. So what I'll do here is I'll use D in the square brackets. I'll be giving the key value that will be equals to the corresponding value for this key. So when I do this, what will happen is this key and this value will be in the format of key value pairs. So let's assign values now to this dictionary D. So first I gave a key value of 100 and the value for that 100 key is 2.3, and for 200 key I have given 4.5 value, and same we have given 300 key the value of 2.3, and 400 key I have given 6.3. Now if I print it, so I'll get all the values in this format. So if you see here, this is our key value and this is the value for that key, and these are separated by commas, and this is the key again, and this is the value, key value, and key value. So all these key value pairs, so this is the pair and this is second pair, third pair, fourth pair, so they are separated using commas. So in this way your dictionary will be printed, and as you can see the data type is dict data type. You can find the length of the dictionary using len function. So here we have the length of dictionary D as 4 because we have 4 key value pairs, that is 1, 2, 3 and 4. So that is the length of the dictionary. And then moving on. Now I want to add a new value. So if I do that, so that value will be added at the end. So we have 100 with a as a key and its value, then 200 and 4.5, 300 and 2.3, this is a pair, and 400 is to 6.3 is one more pair, and then we have 500 is to 5.5. So this is the new one we have added using this. And then now I want to update the value of the key 200. So what I can do is the same thing. I'll be giving D, which is the dictionary name, and the key value I'll be giving in the square brackets equals to the new value. So this new value will be assigned to the key 200. So if I run this, as you can see here, before it was 200 is to 4.5, right? So after performing the updation, as dictionary are mutable, dictionary values are mutable. So I have updated 200 to 9.8 right now. So in this way, I can use updation. And then moving on, here we have the key values are int values and the values are string. So if I run this, so for 10, just a second. So this is a dictionary D1. So for 10 key value, the value is the apple. And for the key 20, the value is mango. And for key 30, the value is berry. And for key 40, the value is kiwi. And it is of the data type dict. And the length of D1 is 4 right now. So now I want to update this key 10. Value is apple, right? So I want to update it with pineapple, let's say. So I'll be giving dictionary square brackets the key value which I want to whose value I want to update, I'll be giving the key value here, and the new value I'll assign using the assignment operator. So if I do this, before it was apple here. So 10 is to apple was there. Now I've updated it to 10 is to pineapple. So this way you can update the values. And then moving on, I have a dictionary whose keys and values are both in strings only. So in this way also you can write a dictionary. So if you see here, we have the keys and values, and if I print it, so this is my dictionary with the key value pairs Python RS, Java JG, and C, DR, .NET MS. So these are like the founders. So the data type is dictionary, and the length of D2 we can find using the length function. So the length here is 4 because we have 4 pairs, key value pairs. So this way your key and values can be both numbers, that is integers, or you can have the keys as integers and the values as strings also. And your key values also can be strings, both can be strings as well. So in this way you can write dictionaries. So as I've told you, the key values cannot be mutable data types like list, set, and dictionary, right? They can only be immutable data types, that is int, float, boolean, string, tuple, and one more frozen set. So if you see here, we are going to demonstrate that. So here the key is a list data type, 1 comma 2, which is a list. So here if you see, it is hashable, unhashable type list. So that is why list cannot be your key, which is the mutable types cannot be your key values. If you see here, we have the key as a tuple. So we didn't get any error, right? If I print D, so the key is a tuple value, which is immutable value. So immutable data type values can be your keys, but they cannot be mutable data types. So in this way, it works. And then there are few functions which we can perform on a dictionary. So they are, firstly, we have a function called as clear. So this clear function is used to remove all the entries of the dictionary object. So you can use it using the dictionary name dot clear parenthesis. So this will remove all the elements, all the entries in your dictionary object. So the first example we are taking 10 is to apple, 20 is to mango, 30 is to raspberry, and 40 is to kiwi. So this is my dictionary D1. And then let's print this. So this is my value. This is my dictionary value and it is stored in a location, this location. So you can get the location using the ID function. ID of, you can give the variable name here and you will get the location where it is stored. So now I am performing d1.clear. So when I perform that, what happens is all the elements in the dictionary D1 will be cleared totally. So if you see, before we had elements in it and the key value pairs. So we have 4 key value pairs before. Now if you see, it is an empty dictionary. So all the elements in the dictionary are removed. And then we have a function called as copy. So this copy function is used to perform a shallow copy. It gives a shallow copy, which means the elements will be copied to a new variable, but it will be stored in a new location. In the same location, the both values won't be stored. That is, they won't point to the same location. So if you see here, we have a D1 with the same values we have used before. So if you print D1, as you can see, the address or the location where D1 is stored is, let's say, 1472. Okay. So now I'm performing shallow copy here. So how you can perform shallow copy is, you can take a new data like the variable name. I'm taking D2 and I want to copy the D1, right? So I can use the equal to D1 dot copy. So this will produce a shallow copy. And then D2 will consist of the same elements. If you see here, we have 10 apple and the same one, mangoes, strawberry, kiwi. With the same key values, all the values will be copied into D2, but they'll be copied into a newer location. So if you see the location difference, so D1 is in 1472 location and D2 is in 8528 location. So these both D1 and D2 are independent of each other. So they won't depend. If you modify D1, that will be only reflected in D1. If you modify D2, it will only be reflected in D2 because they are stored in different locations. Even though they have same elements, they are stored in different locations. So this is how you'll get a shallow copy. So now let me perform some updations or additions. So I want to add a new value, that is key value is 50 and guava is the value. So this is the key and this is the value. So I am adding this to D1 only. So let's print this. So if you see, the 50 and guava are only added in D1. If I print D2 right now, that 50 guava is not added into D2 because they are independent of each other and they have different memory locations. Even if I got the D2 from D1 using the copy function, they both are stored in different locations. So that is why modifying D1 doesn't affect or reflect in the D2. And if you see here, I'm adding a value 60, that is key value is 60 and corresponding value to this 60 key is W million or let's say watermelon, okay? So in D2, I'm adding this. So if you see here, this 60 is to watermelon is only added in D2. Now if I print D1, so that 60 is to watermelon is not printed in D1. I've only updated D2. So that is why it is only shown in D2. That is the new value. As these both are independent, that new value which I have added into D2 won't be reflected in D1. So that is why we don't have 60s to watermelon in D1. So when I perform a shallow copy, the both variables or the dictionary objects are independent of each other and they are stored in different locations. So that's why modifications on one dictionary object won't affect the other one and vice versa. And moving on, we have pop function. So in this pop function, so why we use this is we use it to remove the key value pairs from the dictionary object. So this will pop or remove the key value pairs. But if the key value does not exist in your dictionary, we will get a key error. So you can use this by performing dictionary name, the dictionary name you will be giving, and dot pop. And inside of the pop, we'll be giving the key. So this key and its corresponding value, so both will be removed. So if you see here, we have 10 apple, 20 mango, 30 strawberry and 40 is kiwi. So this is my D1 dictionary right now. And I'm popping the value, sorry, the key, which is 20. So 20 key means 20 is to mango. So this is popped totally. Now if I print D1, I won't be having the value anymore. So that is 20 mango. This is removed. Using the key value, I'll pop the key value pair. That is the value also. So I won't have 20 is to mango anymore. So this is removed totally. So we have 10 is to apple, 30 is to strawberry and 40 is to kiwi. So the remaining elements are there here. Now I am trying to pop the key value 30. 30 means 30 is to strawberry, right? So this whole key value pair will be removed using this pop. So if you see here, we have the remaining elements 10 is to apple and 40 is to kiwi. As 30 is to strawberry is removed using this pop function, we have the remaining elements, that is 10 is to apple and 40 is to kiwi. Now I am trying to pop the key which is 10. So here 10 means 10 is to apple, right? So this total key value pair will be removed. So now I am popping the element and I'll print D1. So now the remaining elements or key values are 40 is to kiwi only. As we have popped all 20, 30, 40, or sorry 10. So as I've removed all these three using these three pop functions, they are removed and the remaining is only 40 is to kiwi. Now I'm trying to pop that key value of 40. So now I have popped 40 is to kiwi also. Now my D1 dictionary is an empty dictionary. So there are no more values. So if I try to pop element from this, so this is an empty dictionary, right? If I try to pop element, that is key is 10. So 10 is not present in our empty dictionary, right? So as we don't have the 10, which is the key in our empty dictionary, we'll get a key error. So this is how you can use the pop function. So moving on, we have a function called as pop item. So pop item, this function is used to remove the last entry. So you'll not be giving any key, specific key value won't be given. Only the last key value pair will be removed. Inside of your dictionary, what is the last key value that will be removed using this pop item function. So how you can use it is the dictionary name you will be giving and dot pop item. So this will directly pop the last key value pair in your dictionary. So now let's try doing that. So we have a dictionary with the keys 10, 20, 30, 40 and the values, corresponding values are apple, mango, strawberry and kiwi. So for 10 it's this and 20, 30, 40. So we have 4 key value pairs in my D1. So these are my values in D1 dictionary. Now I'm using dot pop item. So D1 is my dictionary and dot pop item function. So when I perform this, this will pop the last element or the last key value pair. So the last key value pair, as you can see, it is 40 is to kiwi, right? So this last key value pair is popped. So it will show you what element or the what key value pair it popped. So after popping this 40 and kiwi, the remaining values are 10 apple, 20 mango and 30 strawberry. If I perform one more time the pop item function, so the last value which is 30 is to strawberry, so this key value pair is popped. And then we'll have only two key value pairs which is 10 is to apple and 20 is to mango. So if I try to pop, so pop item function I'm using it again and now it will pop the last entry which is 20 is to mango. So this is the popped item and the remaining items in the dictionary D1 are 10 is to apple. And then moving on, we are popping the last element also. So after popping this last element, we have an empty dictionary. So now if I try to perform the pop item on empty dictionary, we will get a key error which says pop item dictionary is empty. So when you are performing pop item on an empty dictionary, as it doesn't contain any elements, so we'll get a key error which says dictionary is empty. And then moving on, we have a function called as keys. So this keys function is used to obtain all the set of keys in your dictionary. So if you see here, we have the key values as 10, 20, 30 and 40. So if you want to know all the key values in your dictionary, you can use the keys function. So how you can use it is, you will give the dictionary name dot keys. So this will give you all the set of keys, that is the unique values in your dictionary. So this is my dictionary D1, and D1 dot keys will give me all the key values in my dictionary. So these keys are of type dict underscore keys. So 10, 20, 30, 40 are the unique values which are the keys. And you can also get key values using a for loop. So basically here we are printing each value of the keys. So here d1 dot keys will get you this. So 10, 20, 30, 40. So for loop, I'm using for loop to get all the keys to be printed in single line. So what happens is, first your placeholder or your variable k, for k in d1 dot keys. So first k will point to 10 and print k means it will print 10. So that is why it will print 10. And after that, this is a iterable value, right? The keys. So then k will point to 20 and print 20 will happen. So it will print that 20 in a new line. And then k will point to 30 and it will print 30 in a new line. K will point to 40 and then 40 will be printed in the new line. So that is how you can print all the keys of a dictionary using a for loop. So we'll get the output 10, 20, 30, 40. So moving on, we have the function values. So this function is used to obtain all the set of values in your dictionary. How you can use it is, you can use the dictionary name dot values. So using this, you'll get all the values in a dictionary. So values means the apple, mango, strawberry, kiwi. So these are your values in dictionary D1, right? So to obtain all these set of values, you can use dot values function. So if you see here, we have the key value 10. So the corresponding value is the apple. And for key 20, corresponding value is mango. And for key 30, corresponding value is strawberry. And for key 40, the corresponding value is kiwi. So I want all the values. So what I'll do, I'll use the dot values function. So this first d1 equals to the dictionary. I've assigned it. And now I'll use the values function to get all the values in the dictionary. So as you can see, these all values, key values are of type dict underscore values. And all the values are apple, mango, strawberry, and kiwi. So these are the apples in my dictionary D1. And then I can also use the for loop to get the values. So if I do this, I'll be getting all the values. So how this works is, d1 dot values will be giving the apple, mango, strawberry, and kiwi. First, my v value or variable will point to apple, and in place of v, this will be there. So print apple will be performed. So apple will be printed. And when we next it points v to mango. So print in place of v, it will print this value, that is mango, and mango will be printed in a new line. And then v will point to asberry and print asberry. So in place of v, there is asberry, right? So asberry will be printed, which is strawberry. And then we will point to kiwi and print kiwi will happen. So kiwi will be printed. In this way, we can get all the values in a dictionary. And then if we try to get the values in an empty dictionary, it will just produce an empty dict underscore values. So if there are no elements, that is the key value pairs, we'll be not getting anything in a dictionary, empty dictionary. Same goes with keys also. And then there's a function called as get function. So this function is used to obtain the value by passing the key. So if you know, see here 10, it is the key and apple is the value. Again 10, 20 is the key and mango is the value, 30 is the key and strawberry is the corresponding value and 40 is the key and kiwi is the corresponding value for that 40. So if I want to obtain a value, I'll be using key. So if I pass the key, that is 10, 20, 30, 40, I will get the corresponding value to that key. So we can do that in this way also. That is the dictionary name, square brackets. Inside of that, I'll be giving the key value. So this is the key value. So by passing key, I'll be getting the value. So dict of 30. So 30, it corresponds to strawberry, right? That is S-berry. So I got the exact corresponding value. But in this method, if I give the key value which doesn't exist in your dictionary, we will get a key error. So if you see here, I'm using 50. Okay, so 50 is not present in my dictionary, right? Anywhere it is not present. Only I have 10, 20, 30, 40. So if I give a key value which is not present in my dictionary, I'll get a key error. So here, the square brackets are strict in this. So I'll get a key error. But if I use the get function to get my value using the key, I can use in this way. So dictionary name I'll give and dot get, inside of it I'll be writing the key value such that the corresponding value for this key will be given to me in the output. So d1 dot get of 30. So 30 is the S-berry key, right? So I'll be receiving the S-berry in my output. So as you can see, I've used get function and inside of that I've given the key value key, that is 30, and I got the corresponding value S-berry. In the same way, I'm trying to get the value of the key 10. So dot get 10. So that is the key value. The corresponding value is the apple. Okay. So that is the apple. And then we can also use this to get the key 40. So 40 is corresponding value is kiwi, right? So I got kiwi. But if you see here, if I try to perform the get function with the value 50, which doesn't exist in my dictionary, right? So this doesn't exist in my list. I only have 10, 20, 30, 40. So when I do this, it will return none. So get is like a safe operation here. If you don't know that value, the key is present in it or not, you can use get function and it will just give none for us. So it is not present in our dictionary. So here 50 is not present in our dictionary. That is why we got none. There is no key value pair corresponding to this. So here if you see, the square brackets are kind of strict. So if you give a key value which is not present in your dictionary, we'll get a key error. But if I use the get function, we'll just get none. So this is a safe operation. And then we have items function. So this function is used to obtain both the key value pairs. So both the key and value. If you want, you can use items function. So how you can use it is you can give the dictionary name and dot items I can give. So this will give me the key value pairs present in my dictionary. So if you see here, I have the D1, that is 10 is to apple, 20 is to mango, 30 is to strawberry, and 40 is to kiwi. So this is my D1 right now. So now I want to get all the key value pairs in my D1 dictionary. So I can use D1 dot items function. So this will give me dict underscore items. So the data type is dict underscore items here. And all the key value pairs are 10 comma apple, 20 comma mango, 30 comma raspberry, strawberry, and 40 comma kiwi. So in this way, I'll get all the key value pairs. So I can use a for loop also to get them neatly. So here the d1 dot items will correspond to this pairs, right? So when I do key v, so kv, I'm using the variable, and so kv first it will correspond to 10 comma apple, and I'm printing kv. So it will print 10 comma apple, which is this value. And then next it will point to 20 comma mango. So if I print that, it will print 20 comma mango. And then kv will point to 30 comma strawberry next. So that is why when I print kv, 30 comma strawberry will be printed. And then in the same way, 40 comma kiwi is also printed. And if you see here, we can also print them in this way. You can just give some string value in between and also you can print it. So when you have this, the K will point to your values 10, 20, 30, 40, and V will point to apple, mango, raspberry, and kiwi. Okay. So these are like pairs, right? So when your D1 dot items will get that, so that is, it will get these values, right? So K will point to your key values. That is 10, 20, 30, 40, and V will point to your values, which is apple, mango, raspberry, and kiwi. So when you print K comma, so the string is, it's like just the arrow mark. So K, V. So first K will point to 10, right? So it will print 10 and the arrow mark, which is a string value, and the value corresponding value is apple, right? So it will print this way. And the same way it will print 20 to mango and 30 to strawberry and 40 to kiwi. So in this way you can use these items. Now we're gonna learn about the next functions, that is update function. So this update function is used to update one dictionary object with another dictionary object. So I want to update D2. So I want to update all these elements in D2 into D1, okay? So when I want to do this, I can use the update function as D1 dot. So I'm updating D1. So update D2. So all these D2 elements will be updated into D1. So here we have a dictionary D1. So 10 is to Ramu, comma, place. Place is the key here, the string, and Hyderabad is the value. So this is my dictionary D1. Okay. So now I'm printing D1. So if you see here, the 10 and place string is the key values and Ramu and Hyderabad are the values. And in D2, we have key values such as CRS1 is to Python, CRS2 is to Java, CRS3 is to data science. Let's think of them as programming languages. So first language is Python, second is Java, third is data science. Okay. So this is my second dictionary. And if I print that, this is my dictionary. So first dictionary is these values and second dictionary is these values. So I want to update D2 dictionary values, all the key value pairs into D1. So now what happens is I'll be using update function. So D1 dot update of, in the parenthesis, if you give D2, all the D2 values will be updated into D1. So all the key value pairs will be updated into D1. So as you can see, before it had only these values in D1, right? Now it is updated with the D2 values also, that is these. First, this is the key value pair, and second key value pair, and third key value pair. So here only D1 is updated. If you see D2, it still has its only 3 key value pairs. Only this D2 values are updated into your original D1, which had 2 key value pairs. So now it has 5 key value pairs in D1. Only D1 is updated. D2 won't be updated using this function in this case. So now I have one more D1 which consists of 10 is to 2.3, 20 is to 3.4. Okay. So the D1 dictionary consists of only two key value pairs. Now my D2 dictionary consists of 30 is to 3.4 and 10 is to 5.6. So you remember this. So what happens here is when I update D2 values into D1. So the D2 values will be the latest value, right? So if I had, so here if you see in D1, I have already 10 key value and 2.3 is the corresponding value for it. But now I'm updating D2 values into D1. So this 10 will correspond to the new value 5.6 here. So this 5.6 will be updated for the key value which is 10. So if you see here, I'm processing the updation, and if I print D1, so the values of D1 are updated with D2 right now. So if you see 10 corresponds to the new value 5.6 because as I've updated the D2 values into D1, so the new value is 5.6, right? So 10 is updated with 5.6. And then 20 is the same. 20 is to 3.4 and 30 is a new value, right? So 30 is to 3.4 is also updated. So when there are like new element with the same key value, so the new value will be updated to the key value. So that is why in place of 2.3, it is updated with 5.6. So this happens when you update. And if you see here, we have a new two keys. So first D1 consists of Ramu is to C and Raj is to Pascal. Okay. So that is my dictionary. So that is my dictionary D1. And my dictionary D2 is Ramu is to Python and Raj is to Django. So initially my D1 and D2 are this. But if you observe here, the key values are same ones, right? So now what will happen when I update D2 values into D1? The new value will be updated for the key. So this C will become Python because we have Ramu, right? So in the place of the key Ramu, we can only have one value, that is the new updated value. So this in place of C will get Python. And if you see, we have Raj also, the same value we have in D2, but with the other value other than Pascal, we have here Django. So what happens is in place of the key Raj, the new value will be updated. So in place of Pascal, we have Django. So that updation will happen when we use update function. So the latest value will be updated. So if you see here, before it was C and Pascal. So after updating with D2, the D1 became Ramu is to Python and Raj is to Django. So that is how the latest value is updated. Now let's learn about one more data type, which is the sixth data type in Python. So that is NoneType category data type. So this is kind of interesting. So what is none? So is it 0 or is it empty string or is it false? No, it's none of those. None means absence of a value. It doesn't mean 0 or empty string or false, okay? None means the absence of value. The value is not just assigned yet. So when I give x equals to none, it means currently no value is assigned. It doesn't mean 0 or empty string or false or any other. X equals to none means currently no value is assigned. So when I do type of none, I'll be getting class none type. So that's because there is only one none in Python. So there is only one none value in Python. So none is a singleton object. So none is a singleton object. Singleton object means an instance of a class that is limited to a single creation throughout the entire execution of a program. So there will be only one value of a none and it will be stored in a certain location. So even if I give a equals to none or b equals to none, both of these a values will be pointing to the same location because we have only one none value in Python. Both a variable and b variable also both will reference to the same location for this object. So that will be pointing to same location. So that is why none is a singleton object. So there is only one none value in the whole entire Python. So here, when I try to compare a variable with none value, so how we'll compare? Basically, we'll do this, right? I want to compare x with none. So you should never do this. Instead, you should be doing x is none because none is a singleton value, right? So it is a single value. It is stored in a some location. So when you will be doing x is none, so this is like a identity comparison. So when you will do if x is none, that's an identity comparison. That means it will check are both variables pointing to the same object in the memory. So x is it pointing to the same object? And none is also pointing to the same object or not, they'll check. Because none is a singleton value, right? So it will be stored in a single object and there is only one none value. So in that location, the none value will be there. So it will check if x is also pointing to the same location or not as the none. So this is the identity comparison. So when you will do, let's say x a equals to none, b equals to none. So I've told just now, right? What happens is none will be stored in an object and a and b will point to that same object because there is only one value, none. So what happens is when you will do a is b, you will be getting true value because a is also pointing to the same object, b is also pointing to the same object. So a is b will be true. So what this does is this is, that is the relationship operator, will do are these two x and none pointing to the same location or not. So identity comparison will be done here. But if you will do x equals to none, what happens here is this will be doing value comparison. So this will not compare the identities or the locations which it is pointing. This will compare the values. So x value is equal to none or not, this will check. So are both these values equal, it will check. It will not check the memory location. It will check the logical entity or the value is same or not, it will check. So this cannot be correct because this operator is there, right? The comparison operator. This can be changed by the object. So some objects, what they'll do is they'll redefine how this equality will work. So that is why you should not use this equality comparison. Instead, you should be using x is none. That is the membership operation. You should be using this and you should not use this in case of none. So that is why always use this. That is if x is none, we should not be using if x is equal to none. So this is value comparison and this is identity comparison. You should always use identity comparison in case of none because it is a singleton object. So think of it like a when you book a seat in a flight, let's say, and you don't specify the specific seat when you're booking, what will happen is when you're boarding, the seat number will be assigned later, right? So here the current status will be none. That means it is not zero or empty. that seat is not just yes assigned yet, not yet assigned. So none is like that. It is not zero or empty string or whatever. So none is like it's not assigned yet, or it just means currently no value is assigned. So that is how none works, the none value. So moving on, let me look at some code. So here we have a NoneType category. So in case of NoneType category, there will not be any direct constructor like NoneType. So for sets, we have a set function, right? Like set or dictionary or list. So for NoneType, there is nothing like that. So when I do that, it says it is not defined. So there is no NoneType constructor. What you should do is instead, you should be giving a equals to none. So when I give that, a has the value none, so it will point to the location none. So in my environment, none is stored at this location, let's say 1216, okay, for now. So this data type is none type. So in this way, you'll get it. So B is also equal to none. So I'm getting the location of A and B using the ID function. So ID function will give the address. So if you see here, both of them have the same address. So that means, so here, what that means is there's a location, let's say, let's take last four digits, that is 1216, okay? So in this location, my none type object is stored. So both A is also storing a reference which is pointing to this location, and B is also storing the reference which is pointing to the same location. So that is why A's address is also 1216 and B's address is also 1216. So the same number, if you see clearly, in the same address it is pointing. Both A and B are pointing to the same address location. So here I have the membership operation. So in this way only we can check. In the none case, you should use the relationship operator is, and you should check B is none or not. So B is none here, right? So if B is none, print no value. So in this way only you should check. Is not also you should check in the same way. C is not none. But C is none here, right? C is not none. So as C is none, and I gave if C is not none, print no value, right? So it didn't print anything because C is none. And this if condition is false. And you cannot be using in this way because it checks only the value. It won't check the identity comparison like this. So this will do only the value comparison. You should not be doing that. And then now let's know about typecasting. So there are some typecasting techniques. So typecasting is the process of converting one possible type of value into another possible type of value. So that is called typecasting. So in typecasting, we have five fundamental typecasting techniques, which are int, float, boolean, complex, and string. Just a second. So here, so why typecasting is used, let's say. So I want to collect the age of the user. So to get the input from users, we'll basically use the input function, okay? So what happens here is, inside of input, I can give any string also, such that they'll know what to enter. So I'll give enter age inside of this parenthesis. So when I do this, they'll be getting in the output enter age. And if they type 25, let's say, so 25 will be saved into age, right? But even if they gave an integer number, this will be stored as a string only. So this will be stored as a string only. So when I do, let's say age plus 5. So I want to add 5 to the age of the user, let's say. I want to do this option. So what happens is age is string value, right? Here. And 5 is int value. So there will be the clash between the data types. So adding won't be possible. So what you should do is you should convert this age into int. So you can use the int. In that way, you can convert your age into int data type and you can use it. So then if you do this, age plus 5 will be getting 30 because age is 25 and both are in int type. If I do the typecasting, and then we'll get 30. So in this way, you can use typecasting. When you want to change some possible type of value into another possible type of value, you can use typecasting. So what I've just explained is called explicit typecasting. So here if you see age equals to input. So I'm taking input from the user using the input function. So when I perform this, I'll get enter age. So let me enter 25. So now the type of age is string. Okay. Now let me do age plus 5. I want to add 5 to the age. So as you can see, we got a type error because age in string type, but 5 is a int data type value, right? So you cannot add them. So what you should do is you can give int of age to the age value. So it will typecast the 25 string. So what happens is your 25 string will be changed to 25, the int value. So this is a string value. So after typecasting using the int function, so this will happen. So now after typecasting, if you see the type of age, that is the data type, it is int. Now you can easily perform 25 plus 5. Sorry, age plus 5. So easily you'll get 30. So in this way, you can use the typecasting. Or else you can just do what is here. You can just typecast it in the input itself rather than doing the second time. What you can do is you can just give int of, so typecasting is happening for the input enter age. So if I do this, age I'll give let's say 40 and if I print age, so directly here typecasting is done directly at the input level only. So in this way you can get directly the age in int. So there is one more typecasting which is implicit typecasting. So what happens here is, so Python will convert any values automatically when you're doing some operation. So let's say I have a equals to 5, okay? So b is float value. So this is an int value, this is a float value. Now I'm trying to add both a and b. So what happens is when I want to add these both different data type values, so Python will convert this 5 into 5.0 and then it will add it into 3.0. So output will be 8.0 directly. So there won't be any clash. So this is the implicit typecasting. Sir, or implicit casting. So when Python will automatically change the data type, it's called implicit casting. So if you see here, when I do 5 plus 3.0, it directly changes 5 into 5.0 and it will get the output 8.0. And there is explicit typecasting or casting. So what happens is manually programmer will convert the values. So if you see here, I'm giving int, or else let's say I'm giving int of, there's a string value which consists of, let's say 10. So when I do this, it will convert this string value directly into 10. That is an int value. So this is called explicit casting where programmer will manually convert some value into other data type. So this is important. Now let's know about all the 5 fundamental typecasting techniques. So firstly int. So this function is used to convert one possible value into the int type value. So any value, let's say float, boolean, complex. So if you want to change into it, you can use the int function. So float to int typecasting is possible. So what happens is I have 10 a equals 10.23, let's say. So here, when I want to convert, before it is in a float value, right? Now using the int of a, I'm converting it into int data type and I'm assigning it into b. Now the value of b will be directly 10 and the class will be int. So when you change from float to int, this decimal part will directly be removed and only you will get the int, that is 10. The decimal part will be removed totally and you will get the remaining part only. So that is how you got 10 here. And you want to convert boolean to int. So what happens is that is also possible. A equals to, I've given true and I'm converting. So first it is in a boolean type. Now I'm converting it into int type using the int function and assigning it into b value. So b now it is int. So as you know, true is internally worked as 1, right? So true is 1, false is 0. So in the same way, I'm trying to convert false value into int type. So here if you see, initially a is false and it is a boolean class. And now using the int function, I have changed it into int type. So false means 0, right? So we have 0 value and the class int. So the data type is int. And if you want to convert a complex to int, it is not possible because we have here j, right? So this is a complex type, imaginary, real and imaginary type. So we cannot change the complex to int because we'll get a type error. That is, int function argument must be a string, a bytes like object, or a real number. It cannot be complex. So we cannot change complex to int directly. Here, if you see, we have a string value. Inside of that string value, we have a integer like number, right? Whole number. So this can be converted because what happens is the string apostrophes will be removed and our value will have just 123. So before it was a string value. Now after int typecasting, it converted into 123, which is int value. So when your string will have a value which is a whole number, that can be converted into int. If it has float also, what happens is it will not be converted because you have a points here, right? So invalid literal int with base 10. So only base 10 values it will take. That is the decimal number system values like 1, 2, 3 till 10. It will not take values which have this point decimal part or the floating values. So here A consists of a string. In that string, we have a float value, like the decimal point value. You cannot convert this directly because we'll get a value error. But if you want to convert this into int, what you can do is first, you can convert your a value, you can convert it into float value. So what happens is I'll be giving b equals to float of a. Now type of b will be float, right? So this is a initially. And now I'm converting that a into float. We'll learn about float, so don't worry. So b value here is float. If I print that, so b is 12.34 now. Now you can convert this value into int easily. So c value equals to int of b. So b, which is a float value, which is converted from the string a, I'm converting now it into int value, okay? Now if I print c and type of c, now this can be converted into int and the value of C is 12. So as you know, the B value, which is a float value, right? 12.34. So it will remove the decimal part and it will give only 12. So when you want to convert a string which consists of a floating point value into an int, what you can do is you can convert that string first into float and then you can convert that float into int. Directly, you cannot convert this into string to int. If you only have a decimal number system value, In that string, you can convert directly. If you have some floating value, you cannot convert it directly. And also, if your string consists of complex values, so that is also not possible. So it will not convert it. We'll get a value error. And here also you cannot convert when you have a boolean value inside of your string. So true means it is a boolean type, right? So we have a string true inside of the string. So even though it is a string or boolean, how we want, that will not be converted directly into int using the int function. If you really want to convert it, you can convert it first. The string you can convert it into bool using the boolean typecasting, and then that value you can use int function and you can convert it into int. So if we do this process, you'll get 1. But directly when there is a string value of true, you cannot convert it into int. So this is just like a text right now. If you give annuity or true value, it is like a text. So you cannot just change alphabets into numbers, right? Like the int values. So that is why this will not work directly. If you do string to bool to int, this will work. And moving on, if I have a equals to some string, let's say NEUT. So this is also, as I've said just now, you cannot convert it because it is not a number. Inside of the string, there is no base 10 number, which is decimal number system. Numbers are not there. So this is a text. So this text cannot be converted into numbers directly. And then moving on, we have the float typecasting function. So this will convert any of the possible values into float type value. So you can use it using a float function in this way. Instead of this, you can give the variable name or the value name. So here I have an int value which is a equals to 10. So I want to convert this into float value. So firstly, a equals to 10, a is the value 10 and the class or the data type is int. Okay. Now I want to convert it into float. So b equals to float of a. So float of the value 10 will be assigned to b. So when I perform this, so as you can see, B consists of 10.0 right now. And the data type is class float. So this int type value 10 is converted into float. What happens is when you do int to float, just it will add the floating value 0.0. So that is how you can convert int to float. And we can also convert bool to float. So that is also possible. A means A is true here. So true means it is a boolean type value, right? True. So what happens is if you convert this A, which is in a boolean type, into a float type, and I'm assigning that value to B, and I'll print B and the data type of B using this. So the value of B is 1.0 and the data type of B is class float. So as you know, true is internally considered as 1, right? So what happens here is the true value is 1. When I convert this into float, they'll just add the decimal part. So 1.0. So that is what you got here, 1.0. And coming to complex value data type to float, this is also not possible because we cannot convert a complex type into float directly. So the argument here in a float typecasting should be a string or a real number. Then only this float typecasting can occur, but you cannot do it for complex value. So if you see here, the string value has an integer value, right? So inside of string, I have 100, which is a decimal number. So when I try to convert this, what happens is here, if you see, the string consisted of 100 and this is directly converted into float type and the value will be 100.0. So it will add just the decimal part, which is 0.0, and directly you can convert this into float type. So if you see here, this is easier. So inside of the string, we have a floating point value that is 12.34. So what happens is directly you will just remove the apostrophes and you'll have a float value. So this is easier one. So when I do this, firstly it was a string value. Now it is converted into float using the float function. So it is 12.34, which is class float. So data type is float here. And then moving on, we have true value inside of the string. So this cannot be converted into float also. So if you want to convert this, you can use first from this string, you can convert it into Boolean, and from Boolean, you can convert it to float. Then you will get 1.0, but directly you cannot convert this string value. So these are just alphabets here again. TRUE are just alphabets. You cannot convert these direct alphabets into decimal point values, right? So there is no system to convert it that way. So it will not convert. And same for here, inside of the string, we have a complex value. Still, these are just like considered as characters. So you cannot convert these into float directly. If you see here, you cannot convert string to float because your string is in this way. And here we have alphabets Python, which is Python. So you cannot convert the characters directly into float values. So you'll get a value error. So could not convert the string to float, which is Python. And then we have a function called as bool. So this function is used to convert any value into boolean type of value. So how you can use this? You can use bool function. Inside of this, you can give any value, int, float, complex string values. So here in boolean, all non-zero values are true. Non-zero values means except 0 or empty string. All values are non-zero values, so they are all considered true. And all zero values like 0 and empty strings, these are considered as false. So just remember, all non-zero values are true and all zero values are false. So when you try to convert it, if you see here a equal to 1003, so this is not 0, right? We have some value, that is 1003. So this is a non-zero value. So when you convert it into Boolean type, you will be getting true only. So as this is a non-zero value, we'll get true. And if you see here, we have minus 234, 234. So here, this is also non-zero value. Except zeros, all are non-zero, right? So even if it is a negative number, it is a non-zero value. So when you convert this non-zero value into Boolean using the Boolean function, so instead of this Boolean function, you will be giving A, and I'm assigning this Boolean value to B. So when I print B, I'll be getting true because this is a non-zero value and the class is Boolean. And moving on, here I have A equal to 0. So 0 means it is a 0 value, right? So when you try to change or typecast it into Boolean type, you will be getting false because it is a 0 value. And moving on, if you want to convert a float to Boolean, it is also possible because here these are all non-zero numbers, right? So if I convert it using the Boolean type, so Boolean of A, so Boolean of A, this float value, as this is a non-zero number, we'll get true. If you see here 0, 0.0, so 0, 0.0 means 0 only, right? So 0 means we'll get false. So that is why 0 equivalent or 0.0 equivalent is false in Boolean. Here if you see, I have many numbers here, like many zeros here, but at the end I have 1. So this is still a non-zero number. Even if I have too many zeros, I have 1 at the end. So this is considered as 1 into 10 power of something. So that is a non-zero value. So my Boolean conversion will give me true. If I remove that 1, so I have all zeros right now. So this is considered as 0 only. So if I do this, this is a 0 value. So I'll be getting false in this case. But even if I have 1 or 2 or at least slight number, that will still be a non-zero value. And that is a true value. So moving on, we have complex to Boolean type. So this is also possible where the real part, okay, the real part means real plus imaginary. So when I have 2 plus 3j, let's say, if I have a non-zero value, at least at A or at B. So let's say non-zero values. So 2 plus 0j, let's say. In the place of A, I have a non-zero value. If I have a non-zero value of B, let's say 0 plus 3j, or both 2 plus 3j. Even if I have them, the non-zero values, that is the values other than 0 at the real part or the imaginary part or at the both parts, then this is considered as a non-zero and we will get true. We will only get false when both real and imaginary parts are 0. So let's say 0 plus 0j. Only this is considered as false. If we have non-zero values at either real part or imaginary part or both imaginary and real parts, if we have non-zero values, this is totally considered as non-zero value and it is true. If we have zero values at both real and imaginary like this, then we'll get false. So now let's demonstrate that. So here I have a equals to 2 plus 3j. So when I convert this into Boolean, we'll get true. When I have both real and imaginary part as 0, what will happen is I'll get false only. So let's see if we have non-zero part only at real part, okay? So A is 2 plus 0j now. So at least one of the real or imaginary is non-zero, right? So that is why you'll get true. So if I try and keep in imaginary part, I'll keep a non-zero value. So I have 0 plus 5j, a equals to 0 plus 5j. So when I convert this value into Boolean type, still I'll get true because at least one of the part which is real or imaginary part is non-zero value, right? So I'll get true. And if it is both, I'll get true only. So only when both real and imaginary parts are 0, that is 0 values, you will get false. That is this. Only then you will get false. And when it comes to strings, all the non-empty strings are considered true. Non-empty strings means your length should be greater than 0. So if length is greater than 0, you will get true, which is non-empty string. If you see here, we have 1, 2, 3, 4. So the length of this string A equals to, so length of A will be 4, right? So that is why this is a non-empty string and this will give true. So let's demonstrate that. And so we are converting A into Boolean using the Boolean function. So if you see, we got the value true because this is a non-empty string, we got true. If you see here, still this is a float value, we have some values in it and length is obviously greater than 0. So this is also a non-zero value or non-empty string. So we'll be getting true only for 12.34 inside a string. Here, if you see the length, so A equals to 0.0, right? But if you see 0, you'll think it is a false value. But the length of A here, so A equals to string 0.0, right? Length of A is 3. So as length of A is 3, which is greater than 0, so when you convert this into Boolean type, you will still get true value. Just because you have zeros here, you will not get false value. Only non-empty strings will give true and empty strings will give false. If you have any element in the string, it is still true only. So that is why even if the values here are 0.0, it is a length of string is 3, right? So that will be true. Moving on, here we have a string A equal to 2 plus 3j. So it is a non-empty string, right? Obviously, we have some values in it. So this is considered true. And here, even if false is inside of the string, so here the length will be considered mainly when you're converting into Boolean type. So A is equal to false, right? So the length of the string here is 5. So that is why as your length is greater than 0, when you convert this into Boolean type, it is a non-empty string. So true will be printed for this value. If you see here, this still has empty spaces, right? So when you do length of A, so A equal to some empty spaces, let's say. So I'm assigning A that, and length of A here is 4. So length here is greater than 0, right? So now what will be the Boolean value for this when you convert it into Boolean? So that will be true. So let me convert it. So as you can see, as it is a non-empty string, it has some spaces, right? So length is greater than 0, that is 4. So that is why it will be true. But this is the main thing. If you see here, there is no elements here. So this is an empty string. And if I find the length of A also, so A is equal to the value this, right? So it is an empty string. So length of A is equal to 0. So when length of A is equal to 0, that is an empty string. And that when it is converted into Boolean type, that will give me false. As the length is 0, it will give me false. And here, if you see, we have some values. So it is a non-empty string, NEUT. So length will be 4, right? So it is greater than 0. So we will get the value true. And then moving on, I have the complex function. So this will convert any possible value into complex type value. So int to complex, it is possible. What happens is the int value will become the real part of the complex number. So this int part, so complex means real plus imaginary, right? So this int part will be saved as a real part. And in imaginary, 0j will be there. So that way, int to complex is possible. And float to complex is also possible. So here float value will be given as real part only. Same as int. In the real part, the float value equal to minus 2.3 will be given in real part. Plus 0j imaginary part will be added and it will be converted into complex. From float value, you can convert it into complex value. So moving on, we have Boolean to complex. So what happens here is A equal to true I have. So A will equal to true means it is a Boolean type. So when I convert this into complex, what happens is true is internally 1, right? So true means it is 1. Python consider true as 1 internally. So this 1 will be given into the real part. So real part plus 0j. So in this way, you can convert Boolean to complex value. So and then when coming to A equal to false. So if I convert this into complex, so what happens is that 0 only will be, so false means 0, right? So 0 will keep it to real part, let's say. So real plus imaginary. So 0 plus 0j. So finally it is 0j only, right? So that is how we'll get 0j here. In this way, you can convert Boolean to complex also. So here I'm converting the value string to complex. So what happens is the value in the string, which is a decimal number, right? 12. So that will be considered as the real part. So that is why we got 12 plus 0j. And then moving on for the float also, this float value, which is in a floating point value, which is in a string, this will be considered as a real part. So 12.34 plus 0j. That is how you can convert Boolean or like the string value, which has floating point into complex value. And then moving on, A equal to true. So this value cannot be converted into complex because we have a value which is true. These are like just set of characters, sequence of characters. So complex argument is a malformed string. So this string values cannot be converted into complex function. In the same way, A equals to Python. So Python here is a string which consists of sequence of characters. So when I try to convert this into complex, you cannot have this alphabets you cannot have in real or imaginary part, right? So this will not be converted into complex type. So last but not least, we have the string function. So this string function will convert all types of values into string type. So what will happen is I have A equal to 100. So when I try to convert this A into a string and I assign it to B. So what happens is just the 100, which is an int type, will be enclosed in apostrophes. So this will be converted into this. And the float value 12.34, right? So this will be enclosed in a string. So in the same way, all are converted. So you can convert every data type into string data type. So this is the output for 12.34 float value. And if you want to convert a true, a equals to true. So when I do that, I'll convert it into string. So in place of, so before this true is enclosed in a apostrophes. And I have a complex type and 2 plus 3.6j, right? So here, when I try to convert this into a string, just the complex value will be enclosed inside of the apostrophes. So that will become a string. So for today, we have learned about the dictionary data type and NoneType category data type, and also the typecasting techniques like int, float, boolean, complex, and string. So tomorrow we will learn how we can use the print function syntaxes and input function syntaxes, and also we will learn about the operators. So if you have any questions, please put it in the chat box. And that's it for today, guys. This is what we learned. Tomorrow we'll be learning the print function syntaxes, input function syntaxes, and also operators. So if you like our videos, please subscribe to our channel and hit the like button. And if you want to revise the videos or the lives before this, you can go to the playlist Python for AI 2026, which is in our channel. And you can get all the videos from day 1 to day 7. So that's it for today, guys. We'll meet tomorrow. So feedback form will be shared in the chat box. So please wait for that. Thank you.